All right. So the temptation is when you find a point where the second derivative is 0, the temptation is just say, okay, that's the inflection point, we're done. All right. So, but that's not always the case, right? Just because the second derivative is 0 doesn't mean that you have an inflection point there. And so let's take a look at this next example to demonstrate that. All right. If we want to find the inflection point, well, it says find the critical point and the inflection points. All right, well, it's just x to the fourth, right? So, the derivative is just 4x cubed, right? Which means that we have, right, if we set that equal to 0, we have a critical point at x equals 0, okay? Now we could test the critical point to see if that's a maximum or minimum, but it doesn't ask us to do that. It just asks us to find the critical point, right? That's the critical point. Now, if we want to find the inflection points, we need to take the second derivative, right? So we're going to get 12x squared. And then we set it equal to 0. And what did we find? We find that we have a candidate. I'm going to call it a candidate. All right, this is a candidate for an inflection point. Okay, doesn't mean it's an inflection point. We just have a candidate at x equals 0, right? Because that's the only value of x that would make this thing 0. But remember, we need to test it. So let's test. We need to test for a change in concavity, right? Change in concavity. Okay, just want to remind you what we're doing here. We're looking for an inflection point, and it's not an inflection point unless the concavity changes. So we're going to take this second derivative because we're testing the concavity, and we have to test points on either side of the candidate. The candidate is 0, right? So the second derivative is 0 there. So we want to make sure that it's actually changing from either negative to, the second derivative is changing from either negative to positive or positive to negative. So let's pick a point to the left of 0. We'll just choose -1 because that's easy. And if I put that into the second derivative, I square a -1, I get a +1, right? -1 times -1. And then, so I just get 12. It's a positive 12. It's greater than 0, meaning that it's concave up at that point, right? Now, if I test a point on the other side of 0, let's try +1. Now, again, when I square it, I'm going to get +1. So 1 times 12 gives me 12 now. It's still positive, so it's still concave up. All right. So you notice there's no change in concavity. There's no change in concavity. So even though we have a point where the second derivative is 0, if there's no change in concavity, then there's no inflection point. So this function has no inflection points. Okay? So the point of this of this example is that you have to test, right? When you set the second derivative equal to 0, you get a candidate, but you have to test that there actually is a change in concavity. All right, I'll meet you in the next video.